Okay, so solving by elimination. This is, again, the same idea as solving by substitution. You're still looking for the one coordinate that works in both equations. This is just a different way of finding it. So again, I could ask you to graph these lines and look for the place where they intersect, and you'd be finding the exact same thing. Okay? So it's just another way to do it. The key to substitution, the very first thing you had to do substitution was what? What did you have to have for substitution to work? A variable by itself. Okay, so that was sort of the key. Wyatt, you with me? You need to go get a drink or something? Okay, go do something. The key to this one is to get the variables lined up. So see how here you've got the x on top of the x and the y on top of the y. You just want everything to be in the same position. And then you have to get one of the variables to cancel out. So you need one of the variables to have opposite numbers so that when you add together it cancels. Okay, in the first example, that's already done for you. Do you see that you have 3y and negative 3y? That's what you want, okay? So sometimes they're going to hand it to you, just like with substitution. Sometimes they had it already set up for you. Sometimes it's going to be a little bit harder. This one is already set up. So what I'm going to do is I'm going to take these equations and add them together. Okay, you're always adding them. So x plus 2x is 3x. What's 3y plus negative 3y? Big fat 0. That's what we want to happen. Okay, we want that to cancel out. And then 14 plus negative 8 is 6. So now I have 3x equals 6. So what's x equal? Okay, x equals 2. Divide by 3. X equals 2. Okay? Now I still need to go back and find y. And just like before, I'm going to take what I have for x and plug it back into one of my equations. Now this is not going to be as easy as substitution because you don't have any of your equations solved for y equals. I guess if you wanted to do that ahead of time you could. But I'm just going to take this 2 and plug it back into either one of my equations, whichever one looks easier to me. I think I like that top equation. So I'm going to put that in place of x. That's going to give me 2 plus 3y equals 14. And from here I'm just going to solve it like a regular equation. Okay, subtract the 2. So 3y equals 12. I should show that these are two separate equations. Divide by the 3, y equals 4. Okay. So with this method, not as much solving up front. Usually it comes down pretty easy like this, but then to solve for your second variable is a little bit tougher. So then your final coordinate, 2, 4. What do you think? Eh? Like this one? Okay. So let's look at the second one. Is the second one set for anything to cancel out? No, but it's awfully close, right? I sure wish that 2 was what? Negative. Well, I'm going to make it negative. But when I do that, what else do I have to do? Everything in that one equation. Okay? So this is going to change to a negative 3y, and this is going to change to a negative 7. Okay? Now let's add together, and those cancel out. And every time you do this, something should cancel out. Okay, that's the whole point of what you're doing. What's 2y plus negative 3y? Nope, negative 3y. Negative 1y. Negative 1y. 4 plus negative 7 is negative 3. If negative 1y equals negative 3, what does positive y equal?
3.
Positive 3, yep. Y equals 3. Now I'm going to take that and plug that back into either equation. I'm going to go with the top one just since I already messed up the second equation by writing all those negatives in. Anderson?
You know how you made it negative on like the first part of the equation?
Yep.
What if you do it in the middle, do you still have to make everything negative?
Yeah, that's a great question. Yep. And you'll see that later on. But yes, if you change anything in the equation, you've got to change the entire equation. Good question. Now I'm going to take what y equals there, and plug it back in, I guess, to that top equation. So I'm going to have 2x plus 2 times 3 equals 4. Okay, so I put this 3 right there for y, which is really 2x plus 6 equals 4. Subtract off that 6. 2x equals negative 2. Divide by the 2, and x equals negative 1. Okay, final coordinate, negative 1, 3. Good? Okay, let's try number 3. All right, do I have anything that's going to cancel out? Do I have anything where they're the same number and I just need to make it negative? No, not quite. Okay, so think about this. Using multiplication, can I turn a 3 into a 2? I mean, easily? Not really. Can I turn a 2 into a 3? No. Let's look at our y's. Can I turn a 2 into a 6? Yes. So I would really like that to be a positive 6. What would I have to multiply by for that to happen? 3. So I'm going to take this entire equation and multiply by 3. Okay, the entire thing. That's going to give me 9x plus 6y equals, and don't forget, this is the biggest thing that people forget. This number at the end needs to be multiplied by the 3 also. I think that's going to give me negative 78. Am I right? Okay. Now I'm going to take these two equations and add them together. Okay. So I took my top equation, I multiplied everything by 3, which is totally legal in equation solving. Now I'm going to add together my two bottom equations. So I have 11x. Here I have something that cancels out. And negative 10 plus negative 78 is negative 88. Divide by 11. X equals negative 8. Now let's plug that in again to either one of the equations. It doesn't matter which one. I'm going to go with the top one because it's got more positives. Okay? And actually I can plug it into this one too. Doesn't matter really. I've got 3 choices. So I'm going to say 3 times negative 8, because I'm plugging that negative 8 in for x, plus 2y equals negative 26. That's really negative 24 plus 2y equals negative 26. Let's add that 24 to each side. 2y equals, sorry that got kind of crammed, but that's going to be negative 2. Divide by 2, y equals negative 1. Okay. So final coordinate, negative 8, negative 1. Okay, good. What about that next one, number 4? What can you turn into something that would help us?
You could switch the negative to the bottom.
Okay, except that would still have a y on it and that would still have an x. So we need to make sure our x's stay together and our y's stay together. Okay, this one, and I've basically gotten progressively harder. We started, number 1 was already totally set up for you. Okay, number 2 you just had to switch a sign. Number 3 you had to change one equation. What we're going to do in this one is we're going to have to change both equations. Okay? When you're in a situation like this, it doesn't really matter whether you choose to get rid of x's or y's. Okay? What I like about the y's is that you already have this positive negative thing going on. Okay, you already have it where 1 is positive and 1 is negative. What could I turn 5 and 2 both into? 10. Okay, so what do I have to multiply the top equation by to make that happen? 2, and the bottom equation? 5. Okay, so let's rewrite our top equation. I'm going to kind of draw a line there. We're going to end up with 4x plus 10y. And don't forget to do the 15. That's 30. On the bottom, 15x minus 10y equals negative 30. Here I'm going to get 19x. The y's cancel out, which is what's supposed to happen. What's 30 plus negative 30? Big fat 0. Don't let that freak you out. 0 is a number just like everything else. What would I do from here? Divide by 19. What's 0 divided by 19? 0. Yep. So I get that x equals 0. I'm going to plug that 0 back in to, I guess, the top equation. So I'm going to end up with 2 times 0 plus 5y equals 15. What's nice about zeros is basically they cancel out, right? This is gone. So now I just have 5y equals 15. Divide by 5. Yep. Y equals 3. Final coordinate 0, 3. Okay? Okay. Let's look at number 5. What's the problem with number 5? What's that? Okay, it's not lined up, right? The x's and the y's are not lined up. Now, honestly, if I just gave you this problem and I said solve it, I probably wouldn't do elimination on this one. What do you think I would do? Yeah, I would do substitution. That's kind of screaming substitution to me if it's got y by itself already. But if I hand you this and say, here, you have to use elimination, here's what we're going to have to do. We're going to have to move things around, okay, so that we can get them lined up. If I wanted that top equation to match with the bottom equation, I'm going to take this 3x and move it to the other side, okay? When I do that, it's going to become negative. So I'm going to end up with negative 3x plus positive y equals, and then over here I would still have this negative 10. Does that make sense how I moved that around?
Yeah.
I wanted the x's and the y's in the same position. In this bottom equation, I had x and y together on the same side. So in the top equation, I tried to get x and y together on the same side. So I moved the 3x over. When you move it over, really what you're doing is subtracting it, remember? Okay, I really subtracted 3x. So I ended up with negative 3x, positive y, and then over here, I'm left with negative 10. Now, what's nice about this, now that I've done that, yeah, the y's are already set to cancel out, right? You've got a negative y and a positive y. So I can just start adding. This is going to be negative 1x. 6 and negative 10 make negative 4. So if negative x equals negative 4, what's x equal?
4.
Positive 4, yep. Okay. And I can plug that into any equation I want. So I can go back to the original one, I can go to this one that I rewrote, I can go to that middle one, but I like this one because it's solved for y for me. So I'm going to say y equals 3 times 4 minus 10. That's 12 minus 10, which is 2. And so the final coordinate is 4, 2. Okay? Oh, that's okay. Last one, and I'll be honest, this does not happen very often. It's not very often that I would hand you a problem that's mixed up and say, here, you have to solve it by elimination, because I would much rather you look at that and say, here, I want to do substitution. I do think there's a couple on your assignment tomorrow that are like that, and that's why I put that in your notes. But normally I would want you to look at that and say, oh, I better do substitution. Okay? This is about as hard as they get besides this one. That doesn't happen very often. This is about as difficult as it gets. I don't have anything that turns into anything nicely, right? I can't turn a 3 into a 2, or a 2 into a 3, or a 3 into a 4, or a 4 into a 3. Not easily, at least. So I'm going to have to switch both. Which do you feel like, x's or y's? You want to get rid of x's? Okay, so I've got 3 and 2. What do those both turn into? Okay. So I would need to multiply the top equation by 2 and the bottom equation by 3. But what am I forgetting? Because I don't want them to both be 6. I need one of them to be negative, right? Doesn't matter which one. Just take one of these numbers and make it negative when you multiply through, so that you can get a negative 6 out of that. So on the top, I would end up with 6x plus 6y equals negative 6. On the bottom, I would end up with negative 6x minus 12y equals, and that's going to be a positive 30. Add together. Those cancel out. 6 plus negative 12 is negative 6. Negative 6 plus 30 is, positive 24. Divide by negative 6. Y equals negative 4. And then I've got 4 choices for plugging back in. Doesn't matter which one I go with. I'm just going to go with the top one. So I would say 3x plus 3 times negative 4, equals negative 3. Sorry to cram that in on you. Rewrite it nicer here. So 3x minus 12 equals negative 3. Let's add the 12. 3x equals 9. Divide by the 3. X equals 3. Just remember that's backwards, so we need to make sure that when we write our coordinate we put it in the right order. 3, negative 4. How you feeling about that?